When talking about client-side scripting languages, the first thing that crosses our mind is a language that users are able to view and read in the browser. The first language that usually comes to mind is JavaScript. Today, we are going to discuss the client-side scripting language JavaScript, including its strengths and applications. So before we proceed, take a breath, relax, and focus your attention so that you can understand the applications of JavaScript from the beginning. Here are the topics that we are going to discuss: a JavaScript overview, JavaScript data types, JavaScript operators, JavaScript variables and syntax, and sequential control structures with examples. Let us begin with the JavaScript overview. First, let us understand the difference between JavaScript and Java programming. Take note that JavaScript is not Java programming. That is why we need to clearly understand their differences. In terms of type of language. In terms of type of language, JavaScript is a scripting language. It is lightweight, interpreted, and mostly used for web development. In contrast, Java is a general-purpose programming language that is compiled and strongly typed. Regarding execution, JavaScript runs inside web browsers such as Chrome and Firefox, and it can also run on servers using Node.js. Java, on the other hand, runs on the Java Virtual Machine, JVM, after it is compiled. When it comes to compilation, JavaScript is interpreted line by line or just in time, JIT, compiled by browser engines such as V8. Java is compiled into bytecode.class files before it is executed. In terms of typing, JavaScript is dynamically typed, meaning data types are determined at runtime. Java is statically typed, which means you must declare variable types before using them. As for syntax, JavaScript is loosely based on Java and C, but it is more flexible. Java has a stricter syntax and is closer to C++ in structure. Finally, in object-oriented programming, JavaScript uses prototype-based OOP, where objects are created using prototypes. Java uses class-based OOP, where objects are created from classes. In terms of platform, JavaScript is mainly used for web applications, both front-end and back-end development using Node.js. In contrast, Java is used for desktop applications, enterprise software, Android applications, and back-end systems. When it comes to the use of the main method, JavaScript does not require a main method to start execution. In contrast, Java always begins execution with the public static void main, string, args, method. Regarding concurrency, JavaScript is single-threaded and uses an asynchronous event loop to handle tasks. Java, however, is multi-threaded and supports true parallelism using threads. For file extensions, JavaScript files use the .js extension, while Java files use the .java extension. Finally, JavaScript was invented by Brendan Eich in 1995 at Netscape, while Java was developed by James Gosling in 1995 at Sun Microsystems. Now, let us focus on the JavaScript introduction. JavaScript is a lightweight, interpreted programming language. It is commonly used to create dynamic and interactive elements in web applications. It helps developers build powerful front-end and back-end applications using various JavaScript-based frameworks and libraries, such as jQuery and Node.js. JavaScript is widely used all over the world, and major companies like Google, Meta, Microsoft, PayPal, and LinkedIn rely on it for their applications and services. You can also use JavaScript to create dynamic pop-ups on web pages to display different types of notifications to website visitors. JavaScript was developed by Brendan Eich, a computer scientist and programmer at Netscape Communications Corporation. It was initially named Mocha, then renamed LiveScript, and finally changed to JavaScript. The language was later standardized by the European Computer Manufacturers Association, ECMA, under the name ECMAScript, and today, Node.js is one of the most popular JavaScript runtime environments used for building the server side of applications using JavaScript. JavaScript is a dynamic, high-level, interpreted programming language primarily used to make web pages interactive and dynamic. It is one of the core technologies of the web, alongside HTML, which structures content, and CSS, which styles content. JavaScript is an interpreted language with object-oriented capabilities and is single-threaded. It can be used for both client-side and server-side development. JavaScript can be used for client-side scripting, running in the browser to add interactivity such as form validation, image sliders, animations, and dynamic content updates without reloading the page. With server-side environments like Node.js, JavaScript can also run on servers to build backend applications. Additionally, it is event-driven and asynchronous, allowing it to respond to user actions like clicks or key presses and handle asynchronous operations, such as fetching data from an API. JavaScript supports both object-oriented and functional programming paradigms, giving developers flexibility in how they structure their code. It is lightweight and versatile, making it widely used in front-end development, back-end development, mobile apps, game development, and even AI tools. In short, JavaScript brings web pages to life, making them interactive and dynamic. In JavaScript, there are two main programming styles, imperative and declarative. In imperative JavaScript, we write code that explicitly describes each step needed to achieve the desired output, so we are concerned with both the execution flow and the result. For example, to sum all elements of an array, we might use a for loop to iterate through each element and calculate the total. In declarative JavaScript, we focus only on the final output without worrying about the underlying execution flow. For instance, we can use the built-in array.reduce method to sum array elements. Here, we do not need to know how reduce is implemented internally, which makes the code shorter, cleaner, and easier to read. Please observe the example code. This is what we call imperative JavaScript. Why is it considered imperative? Because we explicitly tell the computer how to perform the task step by step. We first initialize a variable, e.g., sum equals 0, then loop through each element of the array using a for loop, and finally add each element to the sum one by one. In other words, we control the exact sequence of operations to achieve the result. Our next example demonstrates what is called declarative JavaScript. Why is this declarative? Because in declarative style, we focus on what we want to achieve rather than how to achieve it. This approach is often shorter, more readable, and easier to maintain. In contrast, the imperative style gives you full control over each individual step, but requires explicitly specifying how the task should be performed. The declarative JavaScript example uses what is called an arrow function, which we can discuss in more detail later. Let me explain how this program works and why it is considered declarative. The arrow function, a, b, equals a plus b adds two numbers, and the dot reduce method applies this function across all elements of an array. The dot reduce method is a built-in JavaScript function that processes an array and reduces it to a single value. Here is the accumulator, which stores the running total or the results so far. B is the current value being processed, and 0 is the initial value of the accumulator. The equals syntax is called an arrow function, providing a shorter and cleaner way to write functions, making the code more concise and readable. Let us proceed to our next topic, JavaScript data types, starting with primitive data types. Primitive data types are the most basic types of data in JavaScript and are immutable, meaning their values cannot be changed once created. These include strings, which represent text, numbers, which cover integers, floating point values, and special numeric values like nan and infinity, and big int, which allows us to work with very large integers beyond the limits of the number type. Booleans represent logical values of true or false, while undefined indicates a variable has been declared but not assigned a value. Null represents an intentional absence of any value, and symbols are used to create unique identifiers, often for object properties. Together, these primitives form the building blocks of data in JavaScript. Next, we have non-primitive data types. Non-primitive types are objects and collections that are stored by reference rather than by value. These include objects, which are collections of key, value pairs, arrays, which are ordered lists of values, and functions, which are callable objects that can be executed to perform tasks. Unlike primitive types, non-primitives are mutable, meaning their contents can be changed after they are created, and multiple variables can reference the same object or collection. The next topic is JavaScript operators, starting with arithmetic and increment/decrement operators. Arithmetic operators perform basic mathematical operations. Addition adds two values. Subtraction subtracts the second value from the first. Multiplication multiplies two values, and division divides one value by another. The modulus operator returns the remainder of an integer division. Increment and decrement operators are used to adjust numeric values by 1. Increment increases a value by 1, while decrement decreases it by 1. Next, we have comparison or conditional operators in JavaScript. These operators are used to compare values and return a Boolean result. Below is a description of each operator to help you better understand their use. Next, we have logical operators in JavaScript. Logical operators are used to combine or modify Boolean values and expressions, allowing you to perform more complex conditional checks. They help determine whether multiple conditions are true or false and are often used in control flow, such as if statements or loops, to make decisions based on multiple criteria. Lastly, we have assignment operators in JavaScript. Assignment operators are used to assign values to variables. The most common is the simple assignment equals, but there are also combined operators like plus equals, dash equals, asterisk equals, and slash equals that allow you to perform an operation on a variable and assign the result in a single step. These operators make code shorter and more efficient when updating variable values. Let us proceed to our next topic, JavaScript variables and syntax. JavaScript variables are used to store data that can be changed later. They can be thought of as named containers. You place data into these containers and then access or modify it simply by referring to the variable's name. In HTML, the script opening and closing tags are used to embed JavaScript code directly into a web page or to link an external JavaScript file. Next, let us discuss JavaScript variable naming rules. Variable names must start with a letter, lowercase az or uppercase az, a $, or an underscore. They cannot start with a number. After the first character, variable names can include letters, digits, 0 to 9, $, or underscore. JavaScript is case sensitive, so small word age, capital A in age, and uppercase age are treated as three different variables. Additionally, variable names cannot use reserved keywords such as let, var, if, for, class, and others. Let us now look at JavaScript methods used to read the values of variables and arguments. Two commonly used methods are console.log and document.write. The console.log method prints output to the browser's console, which can be accessed through the Developer Tools console tab. It is mainly used for debugging and does not affect the visible content of the web page. On the other hand, document.write writes output directly into the HTML document, so it appears on the page itself. It can display text, HTML tags, or both. However, if it is used after the page has fully loaded, it will replace the entire content of the page. To view the output of console.log, open the browser console, a built-in tool in modern browsers like Chrome, Firefox, Edge, and Safari that allows developers to see messages, errors, and warnings, run JavaScript code interactively, and debug scripts. By pressing F12 or Ctrl plus Shift plus J, Windows, or CMD plus Option plus J, Mac, in Chrome/Edge, Control plus Shift plus K, Windows, or CMD plus Option plus K, Mac, in Firefox, or enabling the Develop menu and pressing CMD plus Option plus C in Safari. Why is Browser Console is useful? Debugging: check what's happening in your code. Testing: you can type JavaScript directly in the console and see results immediately. Error tracking shows syntax errors or runtime errors. Inspecting objects: console.log. Object lets you inspect arrays, objects, APIs, etc. Note: the Browser Console is like a playground plus debugging tool for developers, where you can run JavaScript, check outputs, and see errors while a web page is running. Let us observe the difference between console.log and document.write in JavaScript. The output of console.log goes to the Browser Console, which is mainly for developers, while document.write outputs directly to the web page, making it visible to users. Console.log is primarily used for debugging and testing, whereas document.write is used to write HTML or text to the document. Using console.log does not affect the visible content of the page, while document.write does. In terms of data types, console.log can display strings, numbers, objects, and arrays, while document.write mostly outputs strings or HTML. Finally, console.log is considered safe and modern practice, whereas document.write is rarely recommended in modern development. Next, let us discuss JavaScript concatenation. Concatenation means joining strings together. In JavaScript, this is usually done using the plus operator or template literals. By using the plus symbol, you can combine two or more string values into a single string. In JavaScript, we can declare variables in three main ways. The first is var, which is the old way of declaring variables. It was introduced in early versions of JavaScript and is function scoped, not block scoped, meaning it is accessible throughout the function in which it is declared. Variables declared with var can be redeclared and updated. Additionally, console is a built-in JavaScript object that provides access to the browser's debugging console or terminal if using Node.js. And log is a method of the console object used to output information to the console. The second way of declaring variables is let. Let, modern, block scoped, introduced in ES6, 2015, allows you to declare variables that are limited to the block in which they are defined. These variables can be updated but not redeclared in the same scope, and let avoids many pitfalls of var, such as accidental global variables and hoisting issues, making it a safer and preferred choice for modern JavaScript development. Lastly, const is a constant and block scoped variable that was also introduced in ES6, and it must be initialized at the time of declaration and cannot be reassigned. Okay, this time let us proceed to our first complete example program using JavaScript primitive data types and the console.log function. Again, the expected output will be shown in the Console tab or panel. Our next example contains the same variable declarations and primitive data types, but this time we will use document.write, and the expected output will be displayed on the HTML page because document.write can return and display strings and HTML tags directly on the page. In JavaScript, var, let, and const are all used to declare variables, but they differ in scope, reassignment, and usage. The var keyword is function scoped, can be redeclared and reassigned, and is the older way of declaring variables. The let keyword is block scoped, cannot be redeclared in the same block, but it can be reassigned, making it safer and more modern than var. On the other hand, const is also block scoped, but cannot be redeclared or reassigned after it is initialized, which means it is used for constant values that should not change. Thank you for watching part 1 of this JavaScript tutorial. I hope that you learned something about JavaScript so that in our next tutorial, which is part 2, it will not be difficult for you to understand the application. I also hope that you can distinguish the differences between Java and JavaScript, as well as understand the applications and strengths of JavaScript. Once again, thank you and God bless.